Every single time you hop online, you're using something called an IP address. It's kind of like the digital backbone connecting you to, well, everything. But what even is it, really? So in this explainer, we're going to break down the internet's most basic, most fundamental addressing system.
I mean, really think about it for a second. You click a link, you shoot off an email, you start streaming a movie. How does that data from a server, maybe halfway across the world, find its way through this insane maze of networks to land on your screen and not, your neighbor's? Well, the answer to that whole puzzle, it's your IP address.
Okay, so the absolute simplest way to wrap your head around an IP address is to think of it just like a digital mailing address. Seriously, just like the post office needs your street address to drop off a package, the internet needs an IP address to deliver those little packets of data right to your device.
At its very core, it's just a unique address. That's it. It's what identifies a device. And the IP part? That just stands for Internet Protocol, which is basically the rule book for how data gets sent across all these networks. So the IP address is, you guessed it, the address part of that system. It makes sure every little packet of information knows exactly where it's going.
But, just like a city that gets way too big for its original street grid, the internet had to upgrade its address book. It just had to. And this led to two main versions, or protocols, that you'll hear thrown around: IPv4 and IPv6. Think of it like the difference between a tiny town's old phone book and a massive global directory. So on the left, you've got IPv4. That's the OG, the original system. It's based on a 32-bit structure, and hey, for a while it worked great, but then the internet just exploded. Billions of new devices came online, and we literally started running out of addresses. So the solution is over there on the right, IPv6. It's a much, much larger 128-bit system that was built specifically to handle the insane growth of the modern internet.
And here's what that classic IPv4 address looks like. I'm willing to bet you've seen something like this before, right? Maybe poking around in your Wi-Fi settings. It's just a simple 4-part number separated by dots. It's familiar, and for a good long time, it was perfectly fine.
And this is the big problem with IPv4. Its limit, about 4.3 billion unique addresses. Now, back in the 80s, that sounded like an impossibly huge number, more than we'd ever need, right? But today, with our phones, laptops, smartwatches, heck, even our refrigerators are online, we have just blown way past that number.
And this is what an IPv6 address looks like. Yeah, it's a lot longer, a lot more complex, right? It's using a mix of numbers and letters. But this bigger, expanded format, that is the key. That's what lets us create a practically limitless supply of new addresses.
So how many addresses are we talking about? 340 undecillion. Let that sink in. That's 340 with 36 zeros after it. I mean, it's a number so mind-blowingly huge that we could give an IP address to every single atom on the surface of the planet and still have plenty left over. So yeah, we are definitely not running out of these things anytime soon.
All right, so beyond which version of the protocol we're using, there's another really important distinction, and this one happens a lot closer to home. We're talking public versus private addresses, and the best way to get this is to stick with our analogy. It's like the difference between your apartment building's main street address and your actual apartment number.
See your public IP. That's the one single address the rest of the world sees. Your internet service provider, your Comcast or Verizon, they're the ones who give it to you. Now your private IPs, that's a different story. Those are all the internal addresses your Wi-Fi router hands out to your laptop, your phone, your smart TV, all that stuff. They only work inside your own little local network.
So here's an example of a public IP. You can think of this as your network's front door to the rest of the internet. Whenever you go to a website, that website sees this address and knows exactly where to send the data back.
And then you have a private IP, like this one. This is more like the room number inside your house. Your router uses these internal addresses to make sure that CAD video you just had to see goes to your phone and not your roommate's laptop. It's all about keeping things organized on the inside.
Okay, our last big distinction here is all about permanence. We're talking static versus dynamic addresses. And the analogy for this one is super simple. Is your address written in pen or is it written in pencil, where it can be erased and changed at any moment? A static IP is exactly what it sounds like. It's static. It's fixed. It doesn't change. It's like it's carved in stone. But most of us, for our home internet, have a dynamic IP. What happens is your internet service provider has this giant pool of addresses, and it just assigns one to you temporarily. When you disconnect and then connect again later, you might actually get a completely different one.
So you might be asking, why would anyone even want a static, permanent address? Well, Think about businesses that host their own websites with their own email servers. They absolutely need one. They need a super reliable, unchanging address so that their customers can always find them at the same digital spot. Makes sense, right?
So how does your phone or your laptop actually get one of these temporary dynamic addresses? Well, the whole process is automatic thanks to this neat little thing called DHCP. That stands for Dynamic Host Configuration Protocol. Basically, when you connect to a Wi-Fi network, your device sends out a little message asking the router for an address. The router looks at what it has available in its pool and just assigns one to you for that session. It's all a totally seamless, behind-the-scenes handshake.
Phew. Okay. So, we've covered a lot of ground here, right? We've talked IPv4 versus IPv6, public versus private, and static versus dynamic. Now, let's try to put all these pieces together and see why knowing this stuff actually matters.
You see, the main takeaway here is that an IP address isn't just one thing. It has several characteristics all at the same time. For example, your home network probably has a public dynamic IPv4 address that it gets from your internet provider. But at the very same time, your laptop connected to that network has a private dynamic IPv4 address that your router gave it. See? Each of these labels describes a different piece of the puzzle, a different part of its identity and what it does. Because ultimately, your IP address is your unique identifier when you're online. It's pretty much the digital fingerprint you leave on every single website and service you touch. And that, well, that leads us to one last pretty crucial question. Now that you know what your digital address is, who else does? And maybe more importantly, what can they do with